Another interesting example for you. Here I ask you to find the limit of n factorial divided by n to power n as n approaches infinity. Guys, we're going to use algebra and a little bit of elementary calculus. So let us analyze some terms of the sequence. So when n is equal to 1, what do we have? We have 1 factorial divided by 1 to power 1, or 1 over 1, which is always less than equals to 1 over 1 or 1, right? If n is equal to 2, what do we have? We have 2 factorial divided by 2 to power 2, or 1 times 2 divided by 2 times 2, or a half, which is less than or equals to a half. So far I have 1 over 1. Now write it this way so you can see the pattern. When n is equal to 3, we have 3 factorial divided by 3 to power 3, or 1 times 2 times 3 divided by 3 times 3 times 3, which is 2 divided by 9, 2 divided by 9, which is less than or equals to 1/3. Always true. If n is equal to 4, 4 factorial divided by 4 to power 4, or 1 times 2 times 3 times 4, divided by 4 times 4 times 4 times 4. Well, here you can just simplify this. This is going to be 2. So 3 divided by 32. Again, this guy is less than equals to 1/4. I'm trying to find a pattern, find upper bound and lower bound for this sequence. So in general, if I continue this process, n factorial divided by n to power n, which is 1 times 2 times 3 times n, over n times n times n times n, is less than or equals to 1 over n. You can see the pattern here for just basic algebra. But note that all of these values are positive, more than 0. So why I wrote it this way? This is basic algebra. So from algebra, fractions, basically, I have this pattern. Now I'm going to use squeeze theorem. The reason we found the lower and upper bound for an is to use the squeeze theorem or sandwich theorem. So remember that, what was that? It says, hey, if you have a function bounded between two other functions, if the limit of g is equal to limit of h, as a as your variable, whatever it is x, it is n, whatever it is, they are equal to each other, it's equal to L, you can conclude that the limit of f as x approaches to a is equal to L as well. So we are basically sandwiching this function between two other functions. This is a constant function, and this is, well, 1 over n, some part of a reciprocal function. But take a look. 0 is less than an, it's less than equals to 1 over n. The limit of 0 as a constant function, it doesn't matter where the variable goes. You don't have any variable to work with. N goes to infinity, less than or equals to limit of an as n goes to infinity, less than equals to the limit of 1 over n as n goes to infinity. Well, this is basically 0. This is basically 0. 0 and 0, they are equal to each other. So we can conclude that the limit of an as n approaches to infinity is 0. But this limit is 0. You have a convergent sequence. You could graph this and visualize the behavior as well. Take a look at the graph. When n is 1, you have 1. When n is 2, you have a half. When n is 3, you have 2 over 9, which is going to be very close. So this is the behavior of the graph. It's basically approaching 0. What we did, we squeezed this above by 1 over n. Some of the terms are basically the same. And from below by 0. So you're squeezing this function from top and down by two other functions. From top by 1 over n, and from below by 0. So as you can see, as you can visualize, it approaches 0. There is no other option. And we did the calculus and show algebra behind it, the calculation and the whole.